post, edit stuff, and have fun. All right, we are live. And hopefully on YouTube, it's showing up. And we're streaming to Twitch as well.
Hi, YouTube.
Oh, crap. And then now,
you're going to be on YouTube. Your voice
yeah.
if you ask questions.
And actually, if somebody would do me a favor and then click on the next button here and just,
Do you want a clicker?
there we go. Yeah, I don't have one. Do you have one? Oh, yeah. No biggie. This is yeah, we're not a super professional outfit, so anyway, but yeah, so anybody that's out there watching now, thanks for joining us. I am Paul Baylog. I'm the organizer for the STL Go meetup, and then also now here the Kubernetes and Cloud Native meetup. Anybody interested in co-organizing? More than welcome. Oh, is the is that
Yeah, stick that in there. Sure.
yeah, no, go ahead. There we go. Oh, do me a favor and do the allow. Quit that, I guess.
Oh, is it the set up the keyboard?
Yeah.
dance?
Yeah.
Yeah.
Okay.
The keyboard.
There we go. Thank you so much. Okay, I got to get one of these. So, yeah, I just need to, yeah, never really had a need for it before. So, but yeah, so anyway, thank you everybody for showing up. You know, hosting fees are covered for this particular session by CNCF. Facilities, obviously CIC, and then the food is from Honeycomb. So, does everybody confuse that with the cereal by chance?
There's so many things called Honeycomb. What's Honeycomb.io? That's the unique.
the .io. But yeah, so there we go. All right. And then you'll see that a lot of this stuff is badged as St. Louis Go Meetup. We kind of share all the stuff just because I'm lazy and don't want to create two completely separate brandings. So we use that. So it pairs well with STL Go, and then we have the YouTube channel for St. Louis Go. And also, not only our Gophers are our friends, but Tigers are now too. I reached out. I'm actually relocating to Columbia soon, so reached out to the DevComo group, so they are hopefully online and attending that way. So we are growing. I didn't have any other events, so I don't know if anybody has questions, anything, whatever, job postings, yeah, any kind of fun stuff. Yeah, last time I was at least able to talk about KubeCon, but it's passed. Yeah, there's a CDCon is coming up. What is the CD? Continuous Delivery. It's another one from the Linux Foundation. Going to be up in Vancouver. I submitted a paper for that one, so we'll see if anybody else is going.
The conference is Learning from Incidents in Denver next month.
Well, nice. Be nicer, nice and cool.
And
Lots of snow there.
CNCF is doing their first security conference the next week.
That's true. Yeah, I forgot about that. I should have put that on there. I was not organized for this particular event. So anyway, but welcome to Jessica, Jessitron. I'm going to just go ahead and
Sweet.
hand it over to you.
Sure.
Let me switch over the streams. Yeah. Whoop. You need that back. There we go. Whoops. All right. Give me a.
I'm Jessica, and let's just go around the room. What's your name?
I'm Kara Pritchard.
Kara, nice to meet you.
Whoops.
Sam?
Steven.
Steven. That's close. Karen. Steven.
I'm David.
David. Okay.
I don't exist.
Busy evading taxes.
I'll update. Chris.
Chris.
I'm Paul.
Vinod. Yay. Great. Okay.
Oop. One moment. You need.
I need, oh, microphone.
Yes. Microphone check 1 2 1 2.
Clippy microphone. Oh, okay. Sounds different somehow. All right. You want to switch the screen?
You're on. Yeah, you just need to broadcast. Sorry.
What do I need to
the,
do? Oh, do I need to tell it
Yeah,
again?
it'll be
Okay.
on the airplane. Just do the Flame 2, I think.
I need to AirPlay?
Yeah.
Different from the StreamYard.
Yes.
Okay, so don't share my screen on the StreamYard.
Share it on both.
Dude. Okay, am I sharing on
It'll
StreamYard?
be on your display. You'll be able to.
Okay, I was not prepared for AirPlay. It will be where?
Yeah, because everybody online sees your screen, but
Okay,
not in the
But not
room.
in the room.
Yeah.
Okay. How do I do that? I know how to do it with my iPad. But I do
It'll
not
be
know how to
on,
AirPlay with my
displays.
computer.
So if you scroll down there a little bit, and should be displays. Yeah, and then just up at the upper right there, click that plus button, and there should be a
Plus.
Flame 2.
There's a funky fruit. There's a
Not
lime
the funky
green.
fruit. Yeah, not lime green. There should be. Oh,
There's-
there it was. CIC 4220-2 Flame.
Oh, there it is.
Yeah.
I was distracted by the fruit. Okay. The one, oh, there it is.
Oh, and I did want to say too.
Need that. Your laptop.
There we go.
Okay. All right. I did.
You need your microphone too.
Laptop mic, maybe.
No, wait. There's a speaker on behind her, and she's got a mic clipped to her, so that's going to be a problem.
That's not it.
Here we go. Should be able to just.
Right click that, then I can head to the StreamYard and. Yeah, I muted there.
Shut off the camera.
Yeah, that speaker behind her has got to turn off.
Neat.
Can I get it to like not AirPlay sound?
There we go.
Oh,
Oh,
no, that's the TV.
You gotta be kidding me.
Here, you hold this.
Yeah, something about having two computers hooked up to it, maybe? Because it doesn't do this for you, for just you.
Let's see.
I think it's harder when you involve electronics. There's a nice whiteboard over there. Although it would be hard to demo tracing on the whiteboard.
Yeah, that was,
Sounds. Okay, now I'm not hooked up to AirPlay.
oh,
Well, we can fall off.
yeah, you'll have to get back on the airplane.
Yeah.
We got waiting for pairing here.
Yeah,
Trying.
there's, I think, that.
Oh, thanks.
Cheers, free.
Speakers, inputs.
Once this one comes back online, I should be able to mute it from here, I think. I forgot it's got this little panel. Alright.
It's all technical difficulties so far. I missed everything.
Nice.
unmute the microphone.
All right, this thing's successfully paired now.
Input volume down. Okay. There's not a mute button, but okay, so turn the input volume down. That's gonna fuck me up tomorrow.
Yes, it is.
I'll be on the first Zoom call.
8 friends to remind you to put that before you leave.
None of you will be on that first Zoom call.
Before you leave.
Oh, before they, okay, yeah, good point. Okay, so that volume's off. Next, try AirPlay again.
Let's
Displays
see.
plus flame.
This won't let me mute it.
You have to tap the controller to start.
5800 it says until.
Oh, there it is.
Oh, come on, this thing doesn't let you mute.
It's not me. It's not me. Although I actually need to change my speakers again. Because, no, it's outputting to here and then turned off. Okay. Yeah, that thing is an option for output, but that's picked here. Okay, no, don't do that. No, don't, oh God, I accidentally.
And then they got this stuff kind of locked down.
There's an issue in mine. That would be some quick.
Yeah. No.
Do you have
How's that?
maybe?
Wait, maybe?
Woohoo! Okay. Was able to mute it right there. Finally.
Okay, so you muted it on that thing?
Yep. Yeah.
Do you want to give the lav mic back for the, do you need that for the stream?
Oh, do you have that?
Yeah, but no, hand me that mic this time. Thanks. No. Okay, how's the stream looking?
All right. I am seeing your screen on the stream. I'm seeing you
Okay.
on the stream.
Well, my goal,
you
my
have audio?
intention
And
today.
yeah, anybody out there can in Como can confirm that you hear us, that you have audio.
My intention today was to start with the problem. It just wasn't this problem. I actually intend to start with this website. So here is a pretend e-commerce site. It's a real site, but it's only pretend e-commerce. You can click on any of these items and you can add them to cart. And you can even check out as whoever you want.
Oh, sounds like you're not, they're saying you're not getting a good volume, a good level on that mic.
I have 2 blue lights.
There's another one here.
Yeah, we got both of them.
Which one's hot?
Let's see, is the volume, they should both be. They both are. Then maybe the volume on that one get turned down. Test. This one's got good level on it. We'll just switch to that one.
All right, how about this one?
All right.
It's a good thing we have someone paying attention. All right, so you can check out, you can buy this Honeycomb plush. Let's give it the discount of STL Go. Your order is complete. And now this is pretend e-commerce, so you won't actually get a Honeybee plush, but that's okay because you also didn't pay for it. However, you're right, it's the wrong price. That's a different bug. It's a really crappy demo app. It's fine. It's also old. It's like at least 6 months since I made a change to this. So it's legacy. The customers have been complaining that their orders are slow. Just some of them. Checkout is like it's like a second and a half. Maybe it's timing out if they're super impatient. And it's our job to troubleshoot this. So this app runs in Kubernetes. It's in EKS. That part is real. And let's see, they're complaining that it's slow. I mean, when we did it, it wasn't slow. It looked just fine to us, right? Place order, boom, total paid, $0. That was fast. That's not spectacular, but it was fast. And so maybe we click on it a little while, and we'll buy the Toshock has a branch, and we'll try that. Nope, still fast. So we don't know what the problem is. Kashti, how would you troubleshoot this?
Well, I mean, I wouldn't know how to troubleshoot it because I'm only in the beginner Python. But I want to ask why we're worrying about a 2-second wait time for something like this.
Oh, well, because customers have expectations and they're complaining. And it doesn't really matter what we think. Fair. But we are just the developers, and the business people have told us that this is unacceptable, and they pay our paychecks. How's that for a reason? Yeah, they may be mean, but they pay us well, so we're going to try. I'll answer that later. Yeah, I mean, how do you troubleshoot stuff on Kubernetes? Like, seriously, what do you do at work? Anybody? Traces. Of course, that's what we're gonna do today. I was hoping someone would say, "Go look at the logs," so that I could bring up some logs and make faces at them.
Which pod?
I'd love to look at some logs.
You want to look at some logs? Okay, let's see if I can find some logs.
Those are like, really, I just want to see you make faces.
So here's some pods. Maybe let's see. This was in the checkout. It's a checkout, so maybe we'll suspect checkout service here, and we'll get it log. We'll get its logs. K logs pod. There we go. Now we know what the problem is. Logs are things. They're a necessary signal, especially in systems that you don't control or don't have time to update or don't have the rights to. But these days, our standards are higher. And so, yeah, we want to look at traces. So we do have Jaeger implemented here. Let's make it bigger. So Jaeger has traces, and I can select a service. How about checkout? It's totally sus. Find traces. Okay, and we can look at these traces and see there's a little one and there's a big one. And okay, I'm not an expert in Jaeger. Maybe these big ones mean they're slow. That's actually a lot of slow traces. Since 6:42, so that's only the last minute. Look back last hour, find traces. 6:43, okay. Whatever, it'll show us a trace. Okay, so it shows us a trace, and a trace, if you can think of it as log, except that each log has a timestamp, so we can put it on a little timeline here. Each one has a duration, so you can see how long it took. And they have like this tree structure, this like parent-child relationship thing, which expresses causality. So something came in at the front end. That's the beginning of this customer-facing unit of work, and that's the start of a trace. We like to start traces where something enters our system, usually at the back end, because front ends have clock skew, and that's just a mess. So here something entered the back end at the front end service. Why do we call it? It's the back end for the front end. It's not the front end. It's just the front end service, which is on the back end. I didn't name it. Okay. And then that's calling the checkout service, which is calling the cart service. And then it's doing a bunch of other things in checkout. what's it doing? It's doing things like msdemo.productcatalogservice/getProduct. I wonder why product catalog service isn't sending us traces. Sometimes it does. And then it's getting discounts, and then it's getting quotes from the shipping service.
So the logs that the link that you opened up, is that the logs that are?
Good question. So I clicked on one of the lines in the trace. Now, each of these lines is called a span because it represents a span of time and a unit of work. And it has a name. And it's effectively a structured log, plus it always has a timestamp and duration, plus it always has a relationship to the previous one. And every span in here, you can see all its little properties. Not all of them. It's not showing you. The trace ID is an attribute on the span. So once that request arrived, this checkout request here, in the front end service, it was assigned a trace ID. And that trace ID gets passed down everywhere. And I don't know why they're not, I don't know why we're not seeing the other ones, but you know what? We're seeing enough. We're seeing front end and checkout, and that's going to be enough.
What does the logs do? You have 2 entries in there, right?
I have 2 entries. Oh, that. Oh, good question. Okay. This comes from an OpenTelemetry demo app. And in this case, I believe those are OpenTelemetry logs, which contain a trace ID and a span ID. So they associate themselves with this span.
These are the OpenTelemetry logs, not the logs that you showed us, right?
Right. Yes. Now, these might also go to standard out, but the logs that, I don't know what all it's spitting out to standard out. The difference between logs and traces, structured logs, is these relationships with each other. Traces a trace is the higher level word. It's this whole thing for the whole story of this customer experience of the request of how long did this take. They're made of spans. Each span is, well, it usually compensates for several log statements because it's at least got a start and an end, and however many properties are added in. You also, in the code, you don't have to add all the properties at the beginning. Log is construct it, send it, done. A span is construct it, keep it open while you're doing the work so that people can add attributes to it, like, I don't know, net peer port is an HTTP incoming request, so I guess that's interesting to it. And then when there's a separate step to close it, which completes the duration and actually ships it off. But the other thing about these spans is that typically when you create a span, you hold on to that span ID. Like, let's go to this one. This span, does it show us the span ID? No, I don't think it does. Oh, there it is. Oh, yeah, look at it. Oh, there's the span ID. So each of these gets an ID. Is the overall thing, they all share the same trace ID. Each line has its own span ID. It's not showing me the parent span ID, but I can tell you what it is. Because when that span is open, typically when it's the active span, any new span created is going to get that span ID as its parent. And that's how we can reconstruct this tree structure. So the tree structure is constructed on the front end based on all of the spans in this trace, and they're like referring to each other by ID. So logs are construct, send, forget. Spans are construct, hold on to, remember, use as context for the next span, and then send. It's a lot more effort on the part of our programs than logs. It's a lot more effort on the libraries that we use to do this, mainly. We used to do it by hand briefly, but it's also a lot more valuable. It's a lot more effective at telling us what's going on in the program. It gives us a picture to follow. And that's pretty much the definition of tracing. And because it's going from front end to checkout to cart in the same trace, that makes it distributed tracing, because these are running in different processes and different pods. And that trace ID and span ID gets passed along in the HTTP request. And that's called propagation of the trace context. I've got a glossary later.
So the logs here are in context of that span, right, that you're in.
Yes. Yeah. So because they were OpenTelemetry logs, they include the span ID, the trace ID and the span ID. And so Jaeger is able to, like, they might technically be span events that Jaeger calls logs. Not sure. I only ever use Jaeger when I'm trying to give a vendor neutral presentation. Log timestamps are relative to the start time of the trace. Yes, that's nice of them. So from here, can we see what's making this slow? Like, how slow is this one? Took 891 milliseconds. Is that one of the slow ones they're talking about? I mean, it's not a second and a half, but maybe. Why are you, okay. We can shrink these up, and in logs, you might be able to find errors. So when you're looking at failures, you can usually search the log for an error and hope that gives you enough message. Maybe you'll get a stack trace. Here, you get kind of a cross-process stack trace, but also it's higher level. It's not like every function call. It's only important stuff. We only create a span for important stuff, not for every function call. That would be profiling. Different topic. So we can look at what took the longest here, which you can never get out of logs. It's so painful to get that out of logs, but here it makes a nice picture. Email service took 184 milliseconds. Get discounts took 136. Cart took 190. Which of these is abnormal? I don't know. You can go back and maybe we can look at maybe this. Oh, no, that was just get cache size. Okay, that's why it's way smaller. Really, Jaeger, I need you to show me more than the last minute. I don't know why it's only giving me a minute when it says. Yeah, maybe that's it. Let's make that 200. Oh yeah, that helped. Now we're going back to 648. Aha! Thank you, that was totally helpful. Because now we can see, okay, yeah, we were in one of these. Get cache size is its own thing, and that's always fast. But these are called cart checkout. That's what we're after, and some of them are slower. So we were looking at a normal one, and oh look, it took more than 2 seconds. People want to buy stuff really fast. Okay, so what's different about this one? Oh, look at that. Last time get discounts was like 130 milliseconds or something, and now it's 1.7 seconds. And why? Well, it's doing a lot of things, maybe more than before. Some sort of select statement on the database. Yeah, so, and you can look at that. Oh, it looks like the statement is select star from discounts where user is question mark, and it seems to do that over and over. Well, that could be the problem. And now we know where to go looking in the code. And something about these traces is different from these. But we can go look at another one and be like, oh, yep, there's that get discounts again. And the goal of tracing is to get you close enough to the problem that you know which service it's in and where to go looking in the code. I can go search for get discounts in the code, and then I can troubleshoot. So it's not going to get you to the exact function, but it's going to get you close enough to go further. The other thing that's way better about this than this is if you're new to the app. I mean, we're new to this app. This isn't super familiar, but other than front end being in the back end, it's pretty legible. Oh, look, there's product catalog is showing up on this one. Okay, that other one just didn't show up very well. And this one has shipping and cart and email. You can sit here and you can look at this and you can say, wow, I'm new to this company, but I see that when we do a checkout, we have to check product catalog. I wonder why we check it more than once. But then, okay, we've got the discounts problem. We know that's weird. And we're going to go like maybe look for who caused that problem. But okay, we call shipping here and then we call shipping again. All right, whatever. And then we do something to the cart. And then, oh, I see that we send an email. So we send a confirmation email. And then we go back to the front end. So we must be done with the checkout. And now we're calling recommendation service. Oh, and then some more product catalog. Lots more product catalog. Okay, maybe those were the recommendations. You can see like what happened in parallel. Some of this stuff happened at the same time because it's all part of the same causal chain. They're just subunits of their parents, but then you can shrink them up. And you can see that these calls to product catalog, why do we do these sequentially? Why don't we do those concurrently? I don't know. But that's another thing that is good luck in logs figuring out what happened at the same time and what happened before and after and how consistent that is. So this teaches you about what's happening at the same time, and it teaches you about the app that you're supporting. I think this is so incredibly much friendlier to people who aren't already steeped in the particular application. If you're a whiz and you've been working on this app for 5 years or even 2 years, but super dedicatedly looking at logs all the time, then you can go through this and you can watch the tail-f and you can go, oh, I see that something's wrong.
It's like seeing patterns in the matrix.
Yes, exactly. People develop that kind of expertise, but that's not what we need these days when we have all this software and it's like more than can fit in our head all the time. And we need to switch what software we're supporting sometimes. And traces are a lot better. And the good news is the tracing is also a lot easier than it used to be. I mean, it used to be pretty prohibitive. When Honeycomb, for instance, started 6 years ago, tracing wasn't really a thing. And we were like, send the events from your software. Just code it to send the events. That didn't go very well. And then we made some libraries that plug into Rails and made it send useful events that could then be constructed into traces. The Honeycomb beeline, first for Rails and then for lots of other frameworks, latches onto existing frameworks and made the tracing. But it was specific to Honeycomb. And you had to put it in your code and initialize it in your code. And then you could scatter other bits through your code to add attributes to your spans. And then you were kind of stuck. People now using Datadog typically install the Datadog agent everywhere. And it's just everywhere and it's proprietary. And that's a bummer because it's one thing to spend tens and hundreds of thousands of dollars or millions for Datadog to get observability as a service. And it's another thing to tie yourself to that forever. So now we have something better. We have OpenTelemetry. There we go. Now we have slides. Right. So I'm Jessitron. That's fine. Here's some words that we just talked about. I mentioned that there was a glossary. We just talked about tracing and distributed tracing that follows the flow of execution across the process. It really gets your app to tell its story. The trace is the story of one customer-facing event. The span is part of a trace and represents a unit of work that has some importance. Network calls, database calls, these are always important enough to get a span. Sometimes your internal calculations too. And then the trace context is that trace ID and span ID Inside an application, this is typically available globally or in Go in the context object that you pass around. And then between processes, it goes in the HTTP request. It gets propagated across the network. Here's some more words, higher level words this time. Observability means that you can see the internal state of your application just from what it emits, just from the data it emits. Now, this is a pretty broad definition. It's our CTO, Charity Majors, one of the founders, kind of brought this word into software, but it's got its own life now. It does not belong to us. And we can talk about what Honeycomb means by observability, blah, blah, blah. Anything that is giving you clues about the internal state of your software based on its output is observability. Logs are output. Logs tell you something about the internal state. Logs are crappy observability. Metrics. Metrics are often about the server that it's on, but if your app emits metrics to say like how many requests it served and stuff like that, or if you sniff those metrics off the network, which you can often do with agents, you can sniff requests going in and out, and you can supply counts and how long things took and stuff like that. That's observability, but it's not very good compared to when your app is telling its story itself. I like to think of parenting. Software is kind of like parenting because you have a baby, and the baby at first you're like, yay, it cries. That means it works. But then when it's crying for the first year or two, you have to figure out, okay, how long has it been since I changed the diaper? Is it wet? Does it need to eat? Is he cold? Is he hot? Is he just doomed? Because sometimes they're just doomed, and all you can do is wait it out. And you kind of have to guess that because all you have is a red flashing error message of crying. And then they get like signs. I loved it when my oldest started. We went through the baby signs thing, and she could say more and eat. And one time, and this is so much more communicative, right? Because she can really tell us to some degree what's wrong. And tracing is really about that. It's about your software growing up enough to communicate with you carefully. So maybe baby signs are like the structured log level of, we can combine that with the context we have about this particular kid. One time, Evelyn was like 1.5 maybe, and she signed wet, cold. She's sitting at the dinner, wet, cold. And we're like, why are you cold? You're not wet. Your diaper's dry. I'm like feeling in the diaper. It's fine. Wet, cold. She had an ice cube in her diaper. I would not have guessed that, but the signs gave me enough clue to mentally be like, okay, you're right. That was wet and cold. So it's sometimes you learn some stuff that you never knew about your app, like get discounts calls the same SQL statement over and over. That's actually a really common one. You put in tracing in your Rails app and you see the N+1 active record database calls, and you're like, oh, we should fix that. Take the ice cube out of the diaper. Right. So tracing is just really good observability. It's like deliberate observability. Like we put this in specifically to maximize our own learning about what's going on in the system. Observability comes from telemetry. Telemetry is that output that's deliberately about revealing internal state. So logs are telemetry. Because they really are for us to figure out what's going on. But if you've got an agent sniffing network going in and out, that's not telemetry. That's real data that is just piggybacking and doing deductions from. And then instrumentation is the code that sends out telemetry. So a log statement is instrumentation. And all of the code that creates spans and adds attributes and sends them out, all instrumentation. And that's what we want to get into our code without tying ourselves into any vendor. So observability, high-level overview. Our goal is to get those insights into our application state. And we get those, this is us, we're developers / operators. We get those from graphs and traces and logs and a very happy little UI that lets us navigate those things. And that UI gets its data from some database somewhere, a backend data store. OpenTelemetry calls this an OpenTelemetry backend, which makes me mad because the backend includes the front end. But what do? The database is populated with telemetry data, preferably structured events that have relationships with each other, propagated by that trace ID and span ID. And that telemetry data comes from instrumentation code, which emits the events and propagates the tracing IDs over the networks and listens to the tracing IDs that it's on the HTTP request and stuff like that. And this is where OpenTelemetry comes in, this whole side. OpenTelemetry says that everything that's in your code or running in your VPC should be open source. And you can also run this stuff in your VPC. Actually, I would highly recommend separating it as much as possible from your production software, because if your production software goes down, you really don't want this to go down. You really want these to be separate failure domains. But you could still operate it yourself in a different VPC or whatever, different region, different cloud, whatever. But you need that backend data store to store the telemetry. And in this example, it's using Cassandra because that's the default in the Jaeger Helm chart. And Jaeger and Zipkin are the two like open source telemetry front ends. Jaeger is the one in the CNCF.
There's also Grafana Tempo.
And Grafana Tempo. That would be metrics, right? Or is that tracing?
No, Tempo is actually tracing.
Oh, okay.
Yeah, so that's another open source one we have.
Okay. And Grafana Tempo. But Jaeger is the one I've heard of. And it's one of the classics. It was developed by Uber initially, I think. Tempo is tracing?
Yes.
I would not have guessed because Tempo just screams metrics to me.
Yeah, well, we have the LGTM logo, so there's Loki for logs, G is Grafana for dashboards, and
Okay.
T is Tempo for traces,
Oh.
M is Mimir for metrics.
Okay, so it's by first letter.
So it's, yeah.
Okay. Cool. Is that also CNCF?
Yes.
Sweet. Speaking of CNCS, it gets one in a minute. Okay, Honeycomb, we wrote a custom data source just for this. This is our custom database that we operate ourselves. No, you cannot run it in your network. Trust me, you do not want to. We optimize the crap out of this to keep it affordable on AWS. And it's very specific to making all of these graphs and traces and stuff fast. So that's like your as a service. But the good part is this data is in a standardized format, and you can also send it to Datadog, and you can also send it to Splunk, and all the vendors have varying amounts of OpenTelemetry support, and they're all getting there. We deprecated our custom stuff a long time ago, and we only want OpenTelemetry data. So those definitions there. OpenTelemetry is a project in the CNCF, the Cloud Native Compute Foundation. It is, in fact, the second biggest project after Kubernetes by like contributions and activities. And oh my gosh, there's a lot of stuff in it. Okay, so where is OpenTelemetry? What all is it? It's a lot of things. This is a very sad drawing that I made today of an observability pipeline. This is the database that's storing the telemetry or multiple. In fact, this project here, the demo e-commerce app, is sending stuff to Honeycomb and to Jaeger. It's doing that with an OpenTelemetry collector. So the collector is a process that's all open source. It's part of OpenTelemetry. It's a big part of OpenTelemetry. And it's got all kinds of, I can receive data in various formats. So if you have like a Prometheus endpoint over here, the collector will happily pull that for you. And if you have legacy stuff in Open Tracing, Open Census, or Jaeger or Zipkin formats, it's compatible with all of that. So it's backwards compatible with everything, but also defines a very carefully designed with lots and lots of committees and so many meetings. They did all this so you don't have to. There is a standard for tracing metrics and logs over OTLP, which stands for which stands for something on another slide. so you have the OpenTelemetry collector that also runs as an agent often within a pod or a daemon set in Kubernetes. But sometimes you'll have one collector that's sending out, and you'll have other collectors that just run like as a sidecar. They can pull metrics for you and ship them off to the bigger collector. And it's definitely a Swiss Army knife. You can have it process things like, well, that looks like a social security number. Don't send that. You can have it batch things. You can have it sample. You can have it be like, okay, we're actually only going to send half the traces to save money or whatever. You can do a lot in the collector and a growing number of things. Okay, so that's a part of OpenTelemetry and this protocol here, but also inside your applications are the libraries that are doing the instrumentation. There's automatic instrumentation, and that's, I think, no, actually, I have no idea what kind of instrumentation is in this app. I just copied it. But it starts with automatic instrumentation, which is always going to give you the propagation over HTTP and gRPC of the trace context. It's going to give you incoming and outgoing requests. And then because each framework also has its own instrumentation. So there's an implementation for Go, Python, Java, Rust, blah, 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 blah. And there's an implementation for Spring and ASP.NET and Flask and Django and Rails and Sinatra and that one in Go, except there's a couple of them, and they both have auto instrumentation. There's instrumentation for your database clients. So typically you do not have tracing inside your database. That is not something, it's not like an app that you own, but you'll trace all the calls to it. And so that auto instrumentation will live in the database client inside your app. And it'll just be, so there's auto instrumentation that if you use Postgres in Node, you want to bring in this auto instrumentation, and it like interferes with the requires in Node. The implementation is different in every language, of course, but it interferes with the imports and like injects its own code in between your code and the client code and like makes the spans. And that gives you a really good structure. And then if you can add a few custom fields to all your spans, you can make it pop. And I'll show you a little bit of that. At the end, I'll be like, okay, what would this look like in Honeycomb? And show you the pretty traces. Well, I think they're pretty. Right, and that code is also an OpenTelemetry library. So all that stuff is open source, and there's a zillion of these little projects, just piles and piles that you can find. And that gives you the structure of the trace, and then you can modify it if you want to. So OpenTelemetry provides the protocol, gRPC, HTTP. You can use protobuf or JSON. It really, really wants you to use protobuf. I really want to use JSON, but that's just not efficient. But oh my gosh, I can actually troubleshoot it. There's a API specification that's like over all the languages, so we have some consistency, but also there's a per language implementation that's like, okay, you want to call this set attribute, but in Python, that's going to be set underscore attribute. In Java, that's going to be set attribute and camel case, and in .NET, it's going to be capital camel case, and so on. But also in .NET, we actually use the built-in activity structure, and so nothing looks familiar to anyone else because it just looks like Microsoft. Okay, so there's like a compromise here between the OpenTelemetry spec and each language's conventions. And then also semantic conventions are like, what do we call these attributes? Because HTTP status, URL and target and port and there's standard stuff on messaging, and there's a whole lot of there's standard stuff for Kubernetes. What do we call the pod? What do we call the deployment? How do we express the instance and the other bits? So there's a lot of semantic conventions, which I mean, you want to talk about meetings and arguments and bike shedding. Oh my God. These things are like the .NET one is just dying to release 1.0, but it can't because it incorporates the semantic conventions and nobody can agree on the names of these stupid things. Okay, they argue over that so much more than the implementation. I'm glad I'm not on those committees. But yeah, some of my friends are. Right, and so it has all these different auto instrumentations, and that's pretty much OpenTelemetry's scope. The fun part is, one fun part, the part that's going over your network, well, that's not tracing, the part that's going in like your real checkout service requests is even more standardized than that. There's a W3C standard for the HTTP headers for where to put the trace ID and the span ID. Now, AWS, curse you, AWS, and your X-ray tracing bullshit. AWS does not conform to this yet in like, if you use AWS Gateway, and that's really frustrating. But we're getting there. You know, it's not the fastest. It's a big company. This is the standard that everyone is moving to, and all the libraries are going to recognize this. There are a couple other standards that they might also recognize, but this is how we pass trace IDs and span IDs between services, and is extra very standardized. Okay, so we talked about OTLP, which is Open Telemetry Protocol. The L is silent. What is a customer in your app? What is a product? What are the key fields that your app needs? Oh, that's it for slides. Very good. There's some links, blah, blah.
I was going to ask though, too,
yeah.
because you brought
It's a
it
good
up
time for
about
questions.
the, with the collector kind of filtering out some of the traces so you don't trace
Mhm.
everything.
Sampling.
But yeah, what kind of sample rate do you guys recommend? You think?
I
mean, as much as you can absorb.
well, you know, as much as you'll pay for.
Exactly.
But I mean, it vary by URL. If you have a health check, sample 1 in 1,000 or 1 in 100. If you have checkout, you probably maybe want to sample 1 in 5. But the other thing with sampling is that the easy way to do it is randomly. When a checkout request comes in, you decide, we're going to keep this one. And then throughout, you send all the spans. And another one, you'll decide, we're not going to keep this one. And that actually is part of the propagation headers. Like there's a flag for that in the trace context. And then all of those span creations will be no ops. And you won't actually send the spans. But that sucks when the error happens on the one that's sampled. So that's called head sampling, where you decide when it comes in. The other option is tail sampling, where you collect the whole trace and look at the whole thing and then decide whether to sample it, whether to keep it, which is sampling, sampled is kept, or dropped. That's a lot harder. Most people use Refinery for that, which is something Honeycomb open sourced. The collector is getting there.
Does it do something like a check SLI or something, or inject
You
it
can.
in?
It's
If it needs it,
there's
then
so
it's
much
like, don't need to
configuration.
keep
Oh my
it.
gosh. So you can be like, keep all the errors. You can be like, keep everything over 2 seconds that took too long. You can be like, sample 1 in 10, but make sure we get 1 for every customer. You know, spread it out so that we get a representative sample by customer ID or by region or by whatever you think is important, that you wouldn't want to get all of one region and none of the others in a particular 10-minute span of time. So
I think the decision to sample can be done in either the backend or the collector. Right? So that's kind of the
yeah, the tail sampling, the late step is hard because you have to save in memory all of those spans, which usually means if right now, if you can do that in one OpenTelemetry collector, if you can make one that big with that much memory, you can do it in the collector. Refinery clusters, which is why people use that. So that's tricky, but people do it. This demo is not sampling. So we should be able to, for instance, what did we do? We checked out one with, I should figure out how to do this in Jaeger. Tags. We should be able to see app.discount code equals STL go. Last 2 hours. I don't know if that works. Oh, it did find one. Look at that. It found our checkout code because I think this was us. Because I happen to know that discount code is a custom field that does get added, whereas email does not get added. So that's one reason I added it to the UI. And so it found our trace. This is how long it took. It took 800 milliseconds. We didn't even feel it. And I want to show you what this looks like in Honeycomb. So let me go to, in Honeycomb, here's a latency graph. I'm going to fix this. We actually want the latency of everything with no parent span. Does not exist. There. So this is showing us all the top level traces, top level requests, and how long each of them took. A heat map is not a concept that everyone has. So this is a heat map of duration. We're measuring duration. This y-axis is the duration of the root span of the trace, the top level trace that represents the entire customer experience. And higher is slower. X-axis is just time. So to the right is later. But darker is more. So these were just like, there was one request in that time slot that took 2600 to 2700 milliseconds. So we have a light colored, just represents one. There's a little key over there that says we're going from 1 to 35. But there were like 35 requests right here in this really dark spot, and like 18 that took 500 in that time slot, but one that took that long.
So these are root spans?
Yes.
So root spans make up total of all of it, right? Is that part of
The total time of the trace. Yeah, so Honeycomb really does queries not over traces, but over spans. So if you want to make it over the trace, you need to be like, hey, just the span that's at the root. Because we treat all of these as events, and you can query over any event. A log is an event, a span is an event. From the perspective of our database, with some caveats, we actually are starting to index on trace ID. But from the perspective of the database, an attribute's an attribute and we don't care. An event is an event and we don't care, and we're going to make all of it fast. That's one of our specialties. But the fun part is, from this heat map, I can do this bubble up thing, and I can be like, okay, some of these are slow, some of these are not. What's different about the slow ones? And then I can draw.
So, one more
Yeah?
just to
Yeah.
clarify. So the root span would be equal to the trace ID
Oh,
as
yeah.
well, right?
Yes, let me show, actually, let's show a trace. Let's go look at one of these slow ones. So the other thing about Honeycomb is we use the same data source for metrics and for graphs and traces. So you can always click the graph because it's built out of a trace. So here it is. So this, if I add, here it's going to show me, just took off service name. It's fine. It's fine, Jess. You don't need service name. Honeycomb treats all the attributes the same. So this one has a trace ID and a span ID. And the one under it has a trace ID and its own span ID. And that parent ID, DC1FB, also appears in this one. So that the span ID of the root span here is the parent of the next one. If I look for trace.parent ID, I'll see that every span in here has a parent ID except the first one because it's the root. It doesn't have a parent. It is its own cause. So that's why trace.parent ID does not exist. It is secret code for only root span. And having selected these, now here's my favorite part. In the heat map, you can take the bubble, or you can pick bubble up and, oh, I failed. Draw the box better, Jess. You can draw a box around the slow ones and say, what is different? And Honeycomb does a statistical analysis, not AI, not ML, just statistics here, which computers are very good at and is in fact explicable. And it's like, it looks at all the attributes and says, what is different? So the route, the yellow bars are like the percentage of the ones in the box. And the blue bars are like percentage of ones outside the box. So 100% of the ones in the box were /cart/checkout. There were a couple other URLs that the blue ones included. 100% of them were, again, /cart/checkout, same thing. And 100% of them failed our service level indication here. That's a derived field that, yeah, we noticed they're slow. But here's something more interesting. They all have the same discount code. Some of them have banana pants, friends. If I make this, it should have noticed our STL Go one. I don't know, where's STL Go? I don't know. But it's only the yoinks that were slow. So then I can group by that field and it's going to show me results. Oh, let's add like a P90 of duration or something. It's going to show me, okay, here's the yoinks. They're all up there. The rest of them disappear off the heat map. And here's the friend 10s. They were fine. And the banana pants were fine. And the party time, oh, STL Go, we were fine. Just those little ones down there. The blank ones were there's some blank ones that were slow too by the looks of it. But all the yoinks are out there. Oh, do I have, yeah, I do have that. Okay. And then you can like narrow it to that, and then you can go look at it. So you can go between the graphs and the traces. Oh, and when we go into this yoinker here, yoink, which span has that? Okay, it's just this get discounts and the top level. The top level has yoink, and the bottom, the get discounts has yoink, which is good because that's the slow thing that we would expect to be affected by that. But also now you can look at this get discounts and span, and you can be like, wow, 1.7 seconds. Is that normal? And it shows you this little graph up here, which is like, here's all the spans with that service from that service with that same name. And there's a distribution of their durations. And this one's way up high, not down in the dark area. So no, that's not normal. And then, so you can click on that and like do some more things. No results. This is fine. Run query. No. I don't know what that's doing. Go back to my trace. Give me my trace back. There it goes. Right. So that's another of our things. Well, we really like OpenTelemetry because we want you to use our product if our product is the best, not because you're locked in. Everyone should have tracing. If you're implementing an app now, I mean, whatever, legacy is legacy and it can be really hard to update. But if you're implementing an app now, everyone should have tracing and include that. However you give yourself access to it, you can start with something open source and then outsource it if that gets to be a burden. Have fun maintaining your own Jaeger. And then we want you to use OpenTelemetry. We've contributed the project since its beginning because everyone should have tracing, and some people should have this tracing and various other things. I mean, there are reasons. There are circumstances where I'd tell you Honeycomb's probably not the best for you, but I like it. Obviously, that's why I work there. Yeah, that's the story. Tracing, yes. Honeycomb, maybe. We do have the best stickers. No one questions that. So there's lots of stickers over there. Help yourself. I have more. Go for it.
Oh, you want one?
I have more. Thank you for hanging out and listening. Pizza is from Katie's, which is really good, ridiculous gourmet pizza. So if you don't like it, then sorry, it's weird. But it's my favorite, so here it is. Yeah, and we can chit chat and have questions. Thanks, Paul, for organizing. Oh, look, I am bang on time.
Whoa,
That was accidental.
How did that happen? So,
Thanks to the technical difficulties for that.
So any questions? We're gonna switch over here, I guess.
Yeah, or if you want to see code, there's almost every language in this demo project. Oh yeah, let's look at that.
Yeah, if anybody wants to see how the instrumentation is added.
All data sets in demo. No, just give me a query. Group by library.name. This will give us an idea of different languages and stuff. This project is fun. There's some Go. There's some ASP.NET. Oh, we have Redis. Yeah, there's an assortment. So if you want to see what it looks like, we can look at a language fit. Important thing is that you saw tracing being useful.
I'm going to fix the joint discount code.
Yeah, well, let's what I would actually do there is, I think I'm in the right repo. I would go to the top of the repo and I would look for get discounts. I think it's in checkout service. Oh, yep, checkout service, main.go. And I would, let's do cd source checkout service, open that. Don't want to confuse it with all the languages. And that was, let's see, it was in checkout service.go. We can look for get discounts and find where that span is created. Come here, get big. And here it is. In fact, we have a custom span for this one. And you can see that Yoink does something completely different. If it has the Yoink problem, then it loads the discount from the database a lot. Yeah, this is Go. Yeah, so you can see that it mocks this database call just a lot of times. If yeah, it that's on purpose. Yes, yes.
So what we're learning is don't do that.
This demo has been sabotaged, but what matters is that you can see it.
I think we should show something that is not in Go, because Go, you have to write a bunch of instrumentation code.
Yeah, yeah. Whereas like the Python, let's see. Go takes a lot more explicit code because it won't let you do nearly as much
So Go is not a
globally.
good example to demo.
True. Also, this code is rather old, and the people who wrote this version of the demo, there's a newer one that's better. The people who wrote this version of the demo just love custom instrumentation because, I mean, they're on the OpenTelemetry project. It's their thing. Some of these are Python. Yeah. So how about recommendation service? This one, entry point recommendation server.py. I don't know. Usually in Python, it's actually a modification of the Python command. There's like a wrapper if it's using auto instrumentation. This one looks like it's not doing it the easy way. In Java, it's just a command line argument
I think
too.
there's a requirements, right? You should probably look at the requirements. If they're using the OpenTelemetry package.
Oh yeah, I bet they are, but they're probably doing a bunch of custom stuff. Whoops. Look at it all. There's a lot of different packages. So you've got the gRPC and the HTTP, and it's very, very modular and professional. They got something out of all their arguments. Yeah, so if we, I don't know, code dot recommendation server should have some sort of instrumentation. What's it doing? Here it's doing some stuff. OpenTelemetry. The normal amount, there's a normal amount of code to initialize the tracing. Let's see if I can find it.
Doing a lot of manual instrumentation.
Oh, let's look at. There's just getting a tracer. And this one's doing a bunch of custom spans. So it's not very realistic in this sense. If it were using a real database, instead of faking it, it wouldn't need to fake its own spans. You just include the auto instrumentation. And it typically includes the database statement. It typically does not include the parameters because some of that might be sensitive. But it would normally include something like that. So this particular code base is
This is not a good
right.
demo.
The code is messy.
But this is actually, you're writing more instrumentation code than the application code.
Oh, well, yeah, because the app doesn't actually do anything. Realistically, you'll have, where's my other demo? Realistically, with Python, you don't even have to change your code. You can do it all in environment variables and a command line argument. Java, same thing. Go, you will have to change your code. You have to explicitly wrap, for instance, the HTTP libraries because it can't insert itself in your imports in Go. Node, you need a little bit of code, and then you add that as a command line argument. So typically it's very little.
Project in Go to add auto instrumentation.
Oh yeah, sweet. Like in the language?
No, it's using eBPF.
Oh, okay, that makes sense.
It's going to inject code.
See, eBPF, I told you it was important. eBPF injects stuff into syscalls.
Yeah.
Like into the operating system in its own little programming language.
I love it.
Oh,
I didn't know about this. I must learn.
really? Oh, yeah, yeah. Yeah, you'll like eBPF.
The new hotness for sure.
Last QCon had a talk about EPF.
Yeah.
One that people are really excited about.
Yeah, people are really excited about it because it's another way to spy from the outside of your code, but not from the outside of your process, just from the kernel level. It's really sneaky. And that means that you can implement it as ops because the ops people have more control over the kernel than the code. So they can implement tracing, but that's super important for legacy apps that you can't just go and change. That auto instrumentation won't work because this is your custom internal framework.
And you also get a more predictable experience across multiple things. Your Go folks
Languages,
different things
true.
from Python and Java, but you can take it outside of the code. Just let the developers handle the business stuff and let the platform do.
Yeah, but what you miss is what's different about this, the discount code. What you miss is for which customers is it slow?
Right.
Because in the code, like in Java with OpenTelemetry, you can do it all from the outside. In fact, if you're running your Java apps in Kubernetes, you can spin up an operator and have them all instrumented. But then you still have the option in the code of bringing in only the API. Just exactly one library, which is no ops by default unless the agent is in place at runtime. And then you add a few lines of code to add those crucial fields. And that makes your telemetry yours. And it makes it so much more expressive about the app. Yeah. Exciting stuff.
And then there were no questions coming from the interwebs. So, all right. Well, thanks
Sweet.
again.
Thanks.
We switch over here.
Please have some stickers.
I don't think we can send these stickers through the computer.
True. We would have to mail them to Columbia.
Yeah. Well, I'll bring some when I come out.
There you go. Let's see. David, you were at Lambda Lounge. Look, I have some Lambda Lounge stickers. That's a St. Louis history.
That's throwback there.
Yeah.
All right, let me grab the screen here.
All right, that was fun.
Good.
It's very
All right.
bittersweet.
Right.
I miss it.
Right. And this strange loop is going to be the last strange loop.
Yeah, I know. Maybe I should go with this.
You should go. Everybody should go. He gets to have one more big one instead of a bunch of little ones.
It's always so busy.
Mm.
All right. I'll find my slides.
I'm Jessica. Crystal, nice to meet you. Is that with a K or a C?
C.
Cool. What do you do at work?
I maintain Kubernetes, well, many Kubernetes clusters.
Right.
Is 15 many? I don't know.
Yes.
Okay.
Yes, 15 is many.
I know some companies do, but like, hundreds of clusters, and like for each of our users, we have like a 7 we don't have.
Are the 15 identical?
I mean, some are on-prem, some are in public cloud.
Definitely many. Yeah.
Yeah, I don't do a ton of like application
Yeah,
development.
I'm trying to
But
switch
I
over
guess
and find my
it's,
slides again.
This year.
This year I'm supposed to.
Oh,
Yeah.
I have
Well,
so many damn.
I want to
tabs
rewrite the
open.
thing that my team maintains.
excellent.
That's the bad part,
To make it more operable.
I think.
To make the API make sense.
Oh, but that's really hard because then you have to change everything that calls it.
Actually, no,
Yay.
because basically
Okay.
the same way to interact with it right now is through the CLI. So nobody uses the API. So the API is actually very
Oh.
easy to change.
Okay, so you want to make it have an API that people can use.
Yes.
So they don't have to use the CLI.
Yes, it's disgusting. Just like everything.
Bash is
showing
an
up in
API.
CLI is so bad.
Standard in, standard out. Classic.
Grep.
Cool.
All right. Well, I don't have anything else. I was just gonna do the wrap up here. See, I don't think we have any giveaways other than the stickers, so. And the pizza, yeah.
I wanted to get a beef.
We've had like swag in the past.
Yeah, I had K6 t-shirts.
Yeah, I don't have,
couple times.
other than the stickers, I don't have any swag. We do have really nice test and prod t-shirts. I mean, I could give one of those away. I can like send you a link to get a test and prod t-shirt if anybody wants one.
There you go.
They're super soft and they say I test and prod, but they don't say I only test and prod. So calm down. Yeah, if you want one, give me your email and I'll get you a link.
Awesome. All right.
They're
well,
pretty good.
and Broadcast here, and hopefully February 16th is the next one on the schedule, but there's no topic, so if anybody wants to talk, you discover all your eBPF stuff and want to talk,
Ooh.
this is your opportunity.
David gives amazing talks when he does.
Oh my gosh. No, don't, you don't get to sign me up for talks.
No,
It doesn't
no,
work this
no.
way.
No, I don't. No,
But thank you.
but you might get excited about it.
I might. It could happen.
If I may make a comment. I was coming here expecting it to be like this very formal professional meeting that
Oh, hell
talked
no.
about,
Nothing in
you know,
dragons.
programming stuff.
I didn't curse much.
And I get here and just casually says that's sus in the middle of it.
This is formal, Jess.
Exactly. I did not say the F word.
I mean, you're not smashing keyboards.
I haven't, well, no, that was earlier today when I was trying to get this demo to work.
You fix your audio before you put it in.
Oh, yeah.
Oh,
Oh, thanks.
don't forget that.
Thanks.
Yes.
Turn my mic back on.
All
Thank
right,
you.
signing off.